Welcome back. So what we're looking at today is lesson 3, so unit 5, lesson 3, equations for functions. So let's go ahead and jump right in. All right, so diagrams, equations, and descriptions. Record your answers to these equations in the table provided. So we want to match each of these descriptions with a diagram. So the circumference C of a circle with radius R. So if we look, here are our diagrams. So like I said, the circumference C of a circle with radius R. Which one of these diagrams represents that equation? Well, that would be this one here, D. So diagram, not confusing. Okay, diagram A, or description A, diagram D. Sorry, the table's a little confusing. Diagram D. Now our equation would be C equals 2 pi r. And then if we put in 5 for this, 5 times 2 is 10 pi. Now you could also take and multiply the 10 and the pi together. That would be fine as well, but you can leave it in terms of pi. Now, we have independent and dependent variables. So the independent variable is the one that does not rely on anything else. It's the one that we can change and then it affects everything else. So which one is that? That's going to be the radius. It's going to be r. And then the dependent variable is the one that relies on the one we're changing. So that'd be the circumference c. It depends on what the radius is for the circumference. All right. Let's go to description B. The distance in miles, D, that you would travel in T hours if you were driving at 60 miles per hour. So we know we've already used this one. So we're looking at T and D are our two variables, which means that would be this one here. So diagram B for B. Our equation will be D equals 60T. If we plug in 5 times 60 is going to give us 300. And then what's our independent variable going to be? Well, which one can we change? That's going to be the t. And then it affects the distance, depending on how much time we drive. All right. Description C, the output when you triple the input and subtract 4. So in which one are we tripling the input and subtracting 4? Well, that'd be C. So C is C. So for this one, our equation will be y equals 3x minus 4. If we plug in 5 to that, 3 times 5 is 15, minus 4 is 11. Our independent variable is our x. Our dependent variable is the y. All right, and last but not least, our description for D, the volume of a cube V when its edge length is S, which by process of elimination is A, but if we notice S to the third power, that's how we find volume. So V equals S to the third. If we plug in 5 here, 5 times 5 is 25, times another 5 is 125. Now, our independent variable is our S. Our dependent variable is our V, because the volume depends on what the side length is. Side length is just, we can make it anything we want. It doesn't depend on anything. So your keyword for this lesson is equations, because we're building equations off of these models and off these descriptions and being able to figure out our independent and dependent variables. So independent and dependent variables goes back to stuff that you've learned in science as well, hopefully. All right, dimes and quarters. Jada had some dimes and quarters that had a total value of $12.50. The relationship between the number of dimes, D, and the number of quarters, Q, can be expressed by the equation 1/10 D plus 2500 Q equals 12.5. So if Jada has 4 quarters, how many dimes does she have? Well, if we plug in 4 in for Q, we've got 0.1D plus 0.25 times 4 equals 12.5. Now, we know 4 quarters represent $1, so that's 1 whole plus 0.1D equals our 12.5. We subtract the 1 off, so we end up with 0.1D equals 11.5. Now, 11.5 divided by 0.1 is going to give us 115. So there's 115 dimes. Now, if we change this, if Jada has 10 quarters, how many dimes does she have? Well, if we take the 25 cents and we multiply it by by 10, or if we think about it in terms of money, 4 quarters is $1, 8 quarters is $2, so we have $2.50. So we take $12.50 minus $2.50, that's going to give us 10, so we have $10. How many dimes does it take to get to $10? Well, 10 dimes represents $1, so 100 divided by 10, 10 times 10 would give us 100. So is the number of dimes a function of the number of quarters? If yes, write a rule that starts with D equals that you can use to determine the output D from a given point Q. If no, explain why not. So this is yes. We can determine the number of quarters to determine the number of dimes. So D equals, basically what we want to do up here is solve this so we have D by itself. So I'm going to erase what we have here. And change that right there to just our Q. So we would subtract the 0.25 Q from both sides. Now, in doing that, we aren't actually subtracting it. We're just going to write 0.1 D equals 12.5 minus 0.25 Q. Now, we want to divide by the 0.1. So we end up with D equals, I guess I don't need to have that there. And if we take the 12.5 and divide it by 0.1, we're going to get 125 minus 0.25 divided by 0.1 is going to be 2.5 Q. That's supposed to be a Q. So that would be our equation. So we can use that to find out, we could have used this to find this out, and then it'd be a little bit easier because we wouldn't have to worry about subtracting and then moving things around. It'd already be just plug in the quarters, multiply by 2.5, and subtract from 125. So it'd be a little bit easier. All right, for 4, if Jada has 25 dimes, how many quarters does she have? So this is working the other way around. So we're actually going to do 6 first, and then you can see how figuring out how to rewrite it can make solving for these two a little easier than what we did before. So it is yes, we can switch this around and solve for Q. So we had the 0.1 D equals, or not equals, sorry, plus 0.25 Q equals 12.5. So now we're going to subtract the 0.1 D from both sides. So we have 0.25 Q equals 12.5 minus 0.1 D. We're going to divide by the 0.25. So we're going to end up with Q equals, well, 12.5 divided by 0.25 is going to give us 50 minus 0.1 divided by 0.25 is going to give us 0.4 D. So using this equation now, we could take and solve for 4 and 5. So we're going to take 0.4 times 25, which gives us 10. And then we'll do 50 minus 10, which gives us 40. So a little bit easier. The next one, we do Q equals 50 minus 0.4 times 30, just so you can see it. So 0.4 times 30 is going to give us 12. And 50 minus 12 is going to be 38. So it'd be 38 quarters. So having these equations can definitely help in trying to take and solve these, especially when we have them solved to make it the easiest way possible. So we can rearrange equations to take and have a specific variable be the independent versus the dependent, depending on what we're looking for. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.